Welcome, everybody. My name is Marko. I'm an Nginx evangelist at F5, and I'm here to learn Kubernetes. And I hope you're the kinds of community individuals that want to learn Kubernetes as well. So let's learn it together. Um, Obviously, what is the intent behind this? Well, we're going to learn enough Kubernetes to be able to work with it without breaking things. We're going to try to learn enough Kubernetes to be able to take the Kubernetes exams. And what exams am I aiming for? That is a really awesome question. Let's take a look. So here we've got the catalog of the Linux Foundation showing on screen. What I really want to go for is the certifications. So in the catalog, and we'll put these links in the description, in the catalog, you can click on the certification. There's a lot of different types of certification. I'm personally interested in the top 5, the KCSA, Cloud Native Security Associate. This is Kubernetes exam that focuses on security. It focuses on the understanding of security in the context of Kubernetes. Then we've got the Cloud Native Associate. This is your baseline demonstration of understanding the architecture, the terminology, and being able to speak the Kubernetes language. We've got the 3 other Kubernetes certified. There's the security specialist, the application developer, and the administrator. So why do we want to have these? Well, ideally, all of these 5 certifications bring us into a position to be eligible for roll camera. We're going to be eligible to become Kubernetes Kubestronauts. So Kubestronaut is a sort of recognition of passing all these 5 exams. Let me quickly switch my screen to the right screen here. So let me just share my other tab here, the Kubestronaut program. So what is the Kubestronaut program? Well, the Kubestronaut program is essentially a recognition that you've passed the 5 core Kubernetes exams. You get a blue jacket, Kubernetes exclusive Kubestronaut blue jacket, and you got a Credly badge that you're a Kubestronaut. Now, there is another tier, the Golden Kubestronaut. It requires you to pass both the 5 exams that are required for Kubestronaut and then all of the other options that are out there. Well, let's take it step by step. We'll try to do KCNA and KCSA for the start, and then see if we can get to Kubestronaut in a reasonable amount of time. All right. Yeah, that is my personal goal. That is goal that I set up for myself. Why this goal? Well, as you might not know, just recently F5 has become a gold sponsor of the Cloud Native Computing Foundation, which means we're going to need to have a lot of expertise on hand to allow for just answering questions about how the technology that we represent fits into the picture of Kubernetes. And this is going to be one of my essentially roles as an Nginx evangelist. Nginx being a open source program sponsored by F5. Within that program, I'm going to have to sort of be able to be very familiar with Kubernetes, have a lot of expertise on Kubernetes. But, as everybody else, I'm going to be starting from scratch. For now, what we're going to take a look at is some resources, learning resources that I'm personally going to be using. And again, like I said, I'm going to put all the links for all of these things into the description of the video once it's recorded, so that everybody has access to these things very, very easily. So what we're going to do is we're going to take a look at the next tool, which is going to be the glossary. What you want to know when you're starting any kind of learning journey is the ability to essentially know what the words inside of an environment mean. And as all different types of technology platforms, Kubernetes does have some specifics. You might have heard of some specifics about Kubernetes. It's not a container. It's a pod. Well, pods are sort of containers that we can run containers in, if that makes sense. So yeah, the base knowledge is also understanding what the words mean, and the glossary on the Kubernetes.io page really helps us. And we can just take a look at all the little things that we need to understand about what is a certain function. So whenever you get lost when you're learning, bookmark yourself with the glossary, because it is an important part of understanding the technology, the actual glossary, what different terms inside of that technology platform mean. So my personal experience right now, I've had very little interaction with Kubernetes itself. I've previously sort of seen it in operation. I've previously spun up a Minikube and played around with it. And I've previously worked with a cloud provider platform in my previous life that also runs a Kubernetes underneath. So essentially, architecturally, to me, I understand the concepts of the architecture, but I don't have enough experience to be confident to say, hey, I'm going to deploy some applications on your Kubernetes platform, or I'm going to go and pass an exam. Not at all. We're starting from almost zero here. If you've read a little bit about Kubernetes, you probably have the same amount of knowledge as I do. So we're going to go and start with the Kubernetes components. So Kubernetes has a really good public documentation, and everything that I'm showing you is from the public documentation. Everything is essentially online. You can look for it. You can use your favorite search engine, your DuckDuckGo, or whatever you use for search, to find the right type of component, the right type of capability, the right type of documentation that you need. The pages that I'm showing you right now, again, are the pages that I find will be the ones that I will be using to help myself learn more about Kubernetes and prepare myself for the Kubernetes exam. All right, so if we go back to our Kubernetes design, so here are the main components of Kubernetes, right? If I just zoom into this little picture here, we've got a control plane, and that control plane essentially controls what will be deployed on all of the nodes. The control plane has the API server that coordinates all activities. So when we talk to the control plane, we will always be sending commands to the API server, whether we're using some kind of interface, whether we're using some kind of graphical design, whether we're using kubectl or kubectl, as some like to call it. I'm going to call it kubectl. It's kubectl reminds me of cuttlefish too much, so we're going to go with kubectl. Whenever you're using any tool to control it, you're actually sending API commands to the API server, and then this API server will compare your API command, compare your call to the existing configuration that it has, and then it will make changes to the configuration if changes are required. If you're just doing read commands, then it just looks in the database and gives you a response. The database is etcd. etcd is a key value store. So what is a key value store? A key that has a name, like a phone book could be a key value store where it's name, phone number, key value, Marko, and then my phone number. That's a key value store. With etcd, it is designed to be distributed, it's designed to be very fast, scalable, and it's kind of the perfect solution for what we're trying to achieve with our Kubernetes cluster. We're trying to store the existing configuration. When you start a cluster, that means an empty configuration. When you spin up some pods, when you spin up an application, when you spin up a service, then that gets written into the etcd database, and then all the other services now can compare can compare whether the state on the nodes matches the state in the etcd database. If it doesn't match, then the scheduler service will then talk to our nodes, and those nodes will now be able to create different parts of the Kubernetes deployment. You can see that there's two components, the kubelet and the kube proxy on the node. So the kubelet is the one that controls the containers. It takes any instructions from the scheduler through the API. And the node checks into the API and says, hey, are there any changes? And if there are changes in the etcd database, if there's something pending, the scheduler will say, hey, node, deploy these containers. And then we also have the kube proxy. Now, the kube proxy is the networking component, the one that manages the Kubernetes network. Essentially, it establishes all the connections. It enables communication within the network and across networks, across nodes, depending on the configuration. That is the sort of main breakdown of the components that we have inside of Kubernetes. And again, this page, the concepts, the Kubernetes component overview, you got the same thing right over here, all the node components, all the add-ons that we can add. So add-ons essentially give us the ability to extend the basic functionality of Kubernetes. As you can imagine, when you get into tens of thousands of nodes in a big deployment, you can run like hundreds of thousands or potentially millions of containers. You're going to want to have a very well-structured system. So you're going to want to have good name resolution. DNS is very important for cluster-wide DNS name resolution. So if you're not searching for those little Kubernetes modules, you just set up what the DNS standards will be, and then all of the instances register to the DNS, so it's easier to find those devices. You've got the web UI for cluster management, the web interface, like I said before. What it does, it just gives you a graphical representation of the API call that you're making to the API. Resource monitoring for container and cluster level logging. Again, as your cluster scales, what you want to do is you want to have the ability to understand what is happening with your cluster. So container resource monitoring, very important for collecting container metrics to understand, is your application performing well? When you're at thousands of containers, hundreds of thousands of containers, you want to know what's happening. You want to have really good metrics down to the container level, down to the network packet level if you can, because a lot of things can be prevented. A lot of issues can be discovered early. A lot of potential bad deployments can be caught by good monitoring. What I like to say is, when you're running a platform, any platform, Kubernetes, like any other platform, when you're running it without monitoring, it's like flying a plane, but you've got sunglasses on and it's nighttime. I'm not saying you're not going to be able to fly it. You might be a really good pilot and you might be able to fly at night with sunglasses on. It's not a recommended thing to do. You want to keep your eyes on the instruments. You want to take your sunglasses off. You want to keep your eyes on the instruments. You want to see what's happening with the plane. You want to see whether it's pitching up, pitching down, slowing down, speeding up. All of those things need to be kind of mitigated. And this is the same thing that we do. Good resource monitoring at the lowest level possible will help us resolve issues before disasters happen. And then cluster level logging. For good observability, we want to have both the resource monitoring and the logging, so we can then correlate, oh, my resources spiked. Let's check the logs why. We can have a correlation between events that are happening inside of our application and the performance of our application itself. All right. So really, really good stuff. To build a learning environment, we're going to just jump to our next section. Let me just quickly add my content here. We are going to go and see what Kubernetes.io recommends for the learning environment. So yeah, learning environment, kubectl, essentially it's the command line tool that lets you communicate with your Kubernetes cluster. Kubectl, if you prefer that. So Why kubectl? Well, what we want to do is we want to have a lot of ability to do things in a scripted fashion. We want to make sure that we can run commands and then schedule those command runs in a certain specific format. And an easy way to do that is bash scripts. If you have a command that you're running often, or maybe a set of commands that you're running often, create a script, create a bash script. Schedule it in your cron jobs. That's very simple, costs nothing, doesn't require you to learn anything really new, just enough to do most tasks. Now, obviously, you would want to see in production that any deployments, any application components that you're deploying, any changes to your cluster are done through a standardized process, orchestration documents. Pick your favorite orchestration tool. There are so many orchestration tools out there. I'm going to look at orchestration tools later on as we learn more about Kubernetes, as I learn more about Kubernetes, and as you learn more about Kubernetes with me, we're going to learn about that. But first, we gotta learn basic structure of kubectl. And when we learn basic structure of kubectl, we're also going to be able to answer the questions on the exam that are going to be asking us which command does this specific thing. And as we are expecting some of those questions to be there like that, we are going to have to practice with kubectl. So we're going to set up a local environment. What kind of local environment are we going to set up? Two recommendations out of the box. Kind, Kubernetes and Docker. It runs Kubernetes using Docker containers, pretends those Docker containers are nodes. It's very lightweight. It's designed for testing Kubernetes when it's a distributed setup. Now, it really works great for learning, but it does require us to spin up multiple containers, and it can be a little bit complex on the network design because we don't want to mess around with the network as we start learning. So the other option is Minikube. It's a single node Kubernetes cluster for your machine. Really, really easy to build. Super capable little tool. I've ran it before, and I think that for the start, to get through the basic commands, we're gonna go with the Minikube. And then before we jump into Minikube, we also have the quick reference. So quick reference is a really, really nice tool. Let me just quickly switch to the quick reference screen. All right, quick reference. And this one is the one that we want to have sort of, again, bookmarked, available, because it's got all of the references for how do we do something. And this is something that not only will you use it while you learn, keep it bookmarked, because you're going to use it when you get your Kubernetes cluster in production. When you're working with a Kubernetes cluster, always check that you're running the right commands before you do something really, really unnecessary. So this is essentially what we want to have. So yeah, Kubernetes kubectl quick reference. You also have the next chapter right here is the commands. It gives you like an overview of all the commands itself. Do I like that one? I like the quick reference. I like the quick reference because I can search and I can say list, and I can say list. Let's see all list users, list contexts, list all services and namespace, list all pods, and I can just search by that kind of approach. That is what I like to do personally. Now, your mileage may vary, and obviously you might have a different way of doing things. This is something that personally I found works for me. All right, let's go check out the Minikube start. So Minikube, Minikube, there we go. And we'll put that one right here. Minikube start. So this is a really cool page. What you need to run Minikube is 2 CPUs, 2 gigabytes of memory. So really not a lot. Not a lot. Super easy to work with. Prerequisites, there you will need a Docker, or you'll need QEMU or some kind of container or virtual machine manager to work with your platform. So that when you click on those links, so for example, if you click on Docker, it has the ability to show you how to install Docker. You got the steps for installing. For my specific machine that I'm going to be using, I already have Docker installed, so we're covered with that one. You can pick your operating system. Obviously, it picked Windows because I'm talking through the internet through Windows to you. I'm going to pick Linux. I do have a x86 machine. I'm going to go stable, and I'm going to go Debian package because I'm running Ubuntu. And basically what we want is we're going to copy these commands, and that's going to install Minikube. Then we're going to go and say Minikube start. That's going to start our Minikube, and then we can start interacting with our cluster. Once we've done that, we've also got a nice tutorial here, Kubernetes 101. There's obviously lots of tutorials here on the Minikube page, but Kubernetes 101, create a Kubernetes cluster. That is going to be our first essentially task that we're going to do. We're just going to start live coding here. We're going to start. I'm going to share my machine with you. We're going to explore the machine itself. We're going to explore what I'm using for Minikube, and then we're gonna play the game. All right, let me bring up my Linux machine. There it is. Okay, share screen. Can we see it? We can. I'm going to probably have to increase the size of my, how do I do this? I forget. Change settings. We're going to say text appearance. Text, we're going to change the text to a little bit of a bigger text so you can actually see it. All right. Okay. Apply. Come on, apply. There we go. Is that big enough? We're going to go bigger than that. Yeah, we're going to need to go bigger than that. All right. See, this is the kind of thing I have to think about before we start the stream, but unfortunately, I didn't think about that. Let's go to 36. Let's go to 36. Let's go apply. I'm assuming this is going to be good enough. Okay. So yeah, first thing, what do we have for the CPU here? LS CPU. What we have is a very old, 15-year-old i7. That is a very, very old machine, and it will run easily our Minikube. So we do have also 8 gigabytes of memory. We don't really have anything running here. 7 gigabytes is free. We don't have anything running here. So that's going to be plenty of capacity for our deployment itself. All right, let me grab quickly the link for the install of Minikube, which was right here. I'm going to copy and paste that one. All right, let's grab the Debian package. We have the Debian package. All right, let's install the Debian package. That's it. Minikube start. There we go. It's starting. The cluster is being created. It's going to pull all of our components to run Kubernetes version 1.35.1. And then the next step is, deploy something. Like I said, I'm going to go through the tutorial portion, Kubernetes 101 tutorial portion of the Minikube instructions that we have, and we're going to create a cluster and deploy an app. We're just waiting for the cluster to get deployed. All right, Minikube start takes a few minutes. While we have that, we might as well duplicate this tab. We can't because it's not going to show on screen. Yeah, we're going to see. Once it's running, we're going to see when we run an application what the actual compute and memory usage is. I really want to see that kind of state of our environment. Ooh. There we go. Creating Docker container, 2 CPUs, 3 gigabytes of memory. This machine, I bought it a long time ago for very little money. We're talking about maybe like $50 US. And I bought it probably about 6 years ago at least. So it was already 10 years old when I bought it. And it's been a really, really useful machine for these kinds of experiments where I just need a clean computer. So number one, if you want to do that like I'm doing on a remote little machine, you just buy any desktop that's being sold on any refurbished site. And you can install Kubernetes on a Linux machine for basically next to nothing. Or if you want to do that on your laptop, spin up a virtual machine on your laptop and deploy it on your laptop. That is another option as well. Okay, next step, we're gonna see the status of our cluster. We're gonna see the status of our cluster. So first, kubectl version. We don't have kubectl installed. Oh, I forgot to do that. I'm jumping ahead of myself. We're going to install kubectl on our Linux. Let me just grab the link for kubectl. There we go. There's the link to kubectl. What did I download? Oh, I just downloaded. The binary, didn't I? Okay. Let's just install it. There we go. All right. Now kubectl version. There we go. We got the client version. We got the customized version, server version. We're running kubectl now. Okay. So again, next, the reason why I'm doing this live is because probably you might make the same mistakes as me. I'm going to try to find the right process as we discover this one. All right, so let's take a look at our cluster. Minikube supposedly has spun up a cluster. Core DNS is running at this namespace. Kubernetes control plane is running in this space itself. Okay, cool. So we have a running cluster. Now, obviously, I don't have a graphical user interface, nor will I be able to access this address, because this is an internal address, an internal network that was created on our Minikube platform. So we won't be able to do any of that. But we have a running API. So we've got our cluster itself. Okay, kubectl get nodes. Let's see if we have any nodes. We have a node. We have a node called Minikube. It's got running. It runs the control plane. It's been up for 3 minutes. Okay, let's deploy an app. I'm going by the steps of the module 2 of the tutorial, and I'm going to just copy this whole command because it's a long command. All right, kubectl create deployment. I'm going to call it Kubernetes Bootcamp, image registry, Minikube, Kubernetes Bootcamp. This is the deployment that is in that specific link in the Minikube deployer app. All right, let me bring this to our screen just so that everybody sees where I'm getting this from. All right, share this module 2. There we go, and we're gonna show. All right, so this is where we are now. We got the version, we got the nodes. There's one node that's going to be available, and now we're going to deploy this application. This is our Kubernetes bootcamp. Then we're going to check our deployments, and then we're going to view our app as well. We're going to view our app itself and just see what's happening on this instance itself. All right, let's switch back to our other screen. Thank you. Yeah, that's how I tend to learn, is by trying to explain things to others. Now, as I'm learning these command line components and these command line calls, and yeah, that's a question. That's a response from LinkedIn user, whoever you are. Thank you for that chat comment. So basically, what I like to do for learning is I like to learn in a way where I'm explaining to others. And like the reason for this live stream, I'm trying to explain things to you as we go. And if I'm explaining something good, then I know that I'm learning it, that I've learned it to a point where I'm happy to take an exam. If I'm not able to explain what's going on, then that means that I need to learn more. And when you make mistakes, that's really one of the things that you need to also consider. Whenever you make mistakes, you're probably going to learn more. Why are you going to learn more? Think about it this way. If every day when you're doing something, when you're doing a deployment, when you're writing a document, when you're writing an email, when you're troubleshooting something, if everything you did was just right, you did it, done, what would you learn? You'd learn that everything you do goes your way. Nothing then. You learn nothing new. The things that you are doing are the right things, and we don't need to change anything. I like to see when things fail, because when things fail, it invokes your brain to try to figure out why things failed and how can I fix this. And when you fix it, that's when you actually start learning. So breaking things actually is required as a feature of learning things. I hope you don't get too frustrated when you break something, because when you break something, just remember, it's something that is going to help me learn more. All right, let's move on to our deployment. Oh, you know what? This is a better view, I think. Yeah, because you're not seeing half the stuff that's happening. All right, let's keep it in this format. Yeah, sorry, it is my first time on live stream. I've not first time ever, but first time in a long while on a live stream, and I'm kind of rusty. I'm hoping that by next Thursday, we're going to have a better experience. All right, let's create this deployment. Deployment has been created. The next step will be to validate whether that deployment is actually working. So that's going to be kubectl get deployments. Yep, deployments. There we go. All right, Kubernetes Bootcamp is a deployment. So now we should actually be able to see if this is working. All right. So the next step is in another window. So just going to duplicate this one. In another window, we're going to run the command. So let me just copy this. This is the command that we're going to run in another window. We're going to start a proxy, and that proxy is going to allow us to then curl the local host to see whether we're doing anything. How are we doing here on the other side? All right, proxy is started. So we're serving on the local host, and now we're just gonna check and see. Not that. We're good. Yeah. So checking port 8001 on our local host. We've got an application that's running, right? We got an application that's running. We got a response from the platform itself. So we are now good. Cool. And now let's go and grab our pod name and store the environment variable from our pod. That's the next step. Okay. Export pod name. We're going to get pods, our template metadata name, and we're going to export that as $pod name. So when we call up the pod, we're always going to say, so echo pod name should now return Kubernetes Bootcamp pod. That was the reason behind this. All right. So now we can access the pod by running our curl localhost namespaces, default pods, and then pod name at the end. Maybe the size of the text isn't the most appropriate. $pod name is the thing at the end. All right, let's see what we have from the pod name. Oh my goodness, it's all the information about the pod is being served through the proxy. All right. So it's a pod, version 1. It's called Kubernetes Bootcamp. We already know that name, but we're getting it through the API itself. Namespace default. We've got all the information about the pod, what it's doing, what it's running. Kubernetes Bootcamp, it's from this registry, etc. So yeah, that is how we work through our application itself. All right. So now let's explore a little bit of the kubectl components. So kubectl get pods. We've got that pod. We already know that that's its name. So we're going to say next is going to be describe pods. All right. Describing pods gives us essentially the same information, right? kubectl describe pods. We can see that IP address. If we go back into that previous output that we had, there's that IP address. So this is nice JSON formatted output, but if we want to get something in a more human readable format, describe pods is a better way of doing things. So we can describe what's going on in our pods itself. All right, this is where we're going to leave it at this point. So we've got Minikube running. This is going to be your homework. Grab yourself Minikube, set up Minikube, and until next week, you're going to work on Minikube. Now it's time to dive into our last portion of our exam. So what we're going to do now is we're going to use a little bit of AI to help us learn. Why use AI to help us learn? Well, it's a tool. It's there. It's available, right? So what we're going to actually do is we're going to start a project and we're going to build a learning module for our own requirements, for our own needs. So I'm going to use VS Code, and I'm going to use, there we go. I'm going to use VS Code, and I'm going to use Claude to set up a project for just creating to create a project for learning Kubernetes. Why do we do that? There's so many resources on the internet. Yes, there's tons of resources on the internet, and we're going to take a look at some of the resources that exist out there on the internet that I found very useful. But one of the things that you can do with AI is create your own learning platform that you like, how you like to learn. All right. So I'm going to start with, I want to create a learning platform, learning tool to learn Kubernetes. I want to pass the base, the five, five core exam, five core exams that will allow me to become a Kubestronaut. My first exam will be KCSA. KCSA is going to be my first exam, and I might spring this one on you a little bit just in the middle of talking. Yeah, I am planning to take the KCSA exam, the Cloud Native Security Associate, just before the next live stream next week. So wish me luck. Wish me luck. I'm going to hope. My first exam is KCSA. I want 2 types of challenges. Build, sort of challenge me to build something on a Minikube deployment. And I want an exam style set of questions to prepare. That's it. That's what we're going to do. We're going to ask Claude to give us the type of learning that we need. So, like I said, I feel like I'm architecturally pretty comfortable with the terminology, with the design, resiliency, security approaches, but I'm not comfortable with the command line. I'm not comfortable with really building something, like I said. And this is what I need to learn. You might need to learn something completely different. You might need to learn the basics. You might need to learn the terminology. Use AI, right? This can be either free on the free tier or very, very cheap compared to, you know, some learning platforms where it's hundreds of dollars for a course or an exam. And it's customized learning. It's learning built for you. And that's what I always subscribe for. All right. First thing, next thing, while Claude is coming up with some kind of design, let's take a look at the last portion of the recommendations that I've had off of the internet. Let me just quickly switch my screen. I'm going to share my new tab right here. And we're going to go and say the first thing that I really liked as far as free resources, KSUG, Kubernetes user group, a ton of different options right here. They always have Kubernetes discounts for your exams, and they have a bunch of different types of learning. So free learning from all of the names you know already. So really, really useful stuff. I find it super, super useful. So for my specific learning, which will be the, oh, I'm not sharing. Oh, all right. I am not sharing my screen. My apologies. KSUG. Super, super useful stuff. KSUG.ai, discounts for all kinds of different Kubernetes exams. Definitely go check them out. They have a really awesome set of resources here. They have the free learning resources. So lots of different, the link to the free course on Linux Foundation, of course. Lots of different types of content. So yeah, lots of videos, lots of cool stuff. Next, we've got Free Code Camp. Free Code Camp, awesome resource as well for a lot of free stuff. And you'll see that half of these are Kubernetes stamped resources. So really, really awesome stuff there. There's a KCSA mock exam that I already clicked through a little bit, right? So KCSA practice exam, something that really, really useful. And then we've got as well another one. Where is it? There's a lot of other stuff free on the internet. I can't find the link. My apologies. But yeah, use any resources that exist out there. So let's do this. Free Kubernetes learning. Free Kubernetes learning. Wrong tab. Free Kubernetes learning. So many results from like free courses, free tutorials. Go ahead and use all of those. Go ahead and use as much as you can. That's anything that's free. That's the best price. Best price ever. All right. Let's go back to our Claude. Let's see what Claude came up with. All right. Let me build a comprehensive KCSA learning tool. It'll be a Python app with 2 modes: exam practice modes with explanations and Minikube lab challenges. I'll design it so the other 4 cubes around exams can be added later, starting the build now. It's gonna build an app for me. It's gonna build all the required components for me. Let me just add this back to stage so you can actually see what I'm talking about. So yeah, Claude says, yep, I'm gonna help you with that, man. Marko, you need to learn. There you go. There you go. I'll build a tool for you. Anything that I build over here, you're gonna find it on my GitHub. I'm gonna help you learn with all this stuff that's right here. So if it's good enough to share, which probably will be, what we're gonna do is I'm gonna make that available on my GitHub for free for everybody. So as I build more components to this thing, it's all gonna be freely made available to you. All right, let's take some comments. I started Kubernetes 2 years back. Every day, it's new learning. Excited, yeah. This is the kind of thing that you never stop learning. I've got probably over 15 years of experience in cloud, and it's basically just a journey of continuous learning. In the 15 years, cloud has changed probably like at least about 4 times. Fundamental changes in cloud were introduced at least about 4 times. And that doesn't even say anything about the release of new services, the release of capabilities that are happening, the release of different types of components. It says nothing about that. So really, I totally agree. It is a continuous learning process. And one of the advices, my favorite advice to give is don't stop learning. Every day is going to be an opportunity to learn something new. And when you have an opportunity to learn something new, never say no to that opportunity. It might be scary sometimes. It might be difficult to find time to learn something. It might be just not the right time for you, but try it. Try to learn the thing. If you have an opportunity, go learn it. I wouldn't be where I am if I said no to one of the opportunities that I had. Started with the early days back. I was a service technician. I was fixing PCs, and they said, "Do you want to learn how to fix laptops?" I said, "Yes." They sent me to a course. I learned how to fix laptops. I learned how to fix laptops really, really well at that point in time. Then I went on to a server course. Then I went on to learn about operating systems. First, Microsoft Windows was a big thing back then. I got myself to MCP and then MCSA on Windows 2000, later Windows 2003. And then somebody said, "Hey, you're good at Windows. Why don't you figure out Linux. And I said, well, yeah, sure. What is Linux? And I started just like I'm starting today. I kind of knew what an operating system was. I didn't know the terminology. I didn't know the philosophy behind Linux. And it took a long time to figure out how to work with Linux. So I went, they took some courses, did some learning. I passed the RHCE, Red Hat Certified Systems Engineer, RHC, Red Hat Certified Engineer. Yeah, Red Hat Certified Engineer. Yeah, and maintained that throughout like Red Hat 3 and 4 and 5. So that was a tough exam. That was like a 5-hour hands-on exam on Linux. That was a really tough exam. No multiple choice, really, really tough exam. Then later on, I had 2 operating systems that I was working on. Virtualization became a thing. I started learning about virtualization, started learning about VMware, ZenSource before Citrix bought it. Then obviously Citrix Zen when it became Citrix. And then naturally that kind of led into cloud. All the storage, networking, and virtualization knowledge led into cloud. And then in cloud, I started learning about data analytics. I started learning about how to handle massive amounts of data, logs, metrics, how to analyze them, how to use machine learning to gain insights from all of that. All right, so let's allow Claude to do its thing, and then we'll take a look at what it came up with. So yeah, basically, you can see how each thing that I said yes to led me over into that new direction, right? And then I spent 15 years in cloud, first doing a lot of OpenStack. Well, actually, even before, we kind of built some clouds on VMware, then on OpenStack, then I got into AWS, and I spent some time at AWS, and then now I'm in the open source world again. Nginx, Kubernetes, these are the things now, and it's all about saying yes to opportunities to learn, which sometimes are scary. A lot of my peers at the same moment in time said no. Yeah, that's my best advice that I can give you. All right, what do we have? We have 40 KCSA exam questions, all 6 domains, easy, medium, hard. We have 10 Minikube lab challenges from beginner to advanced. We got the question domains and hands-on labs, least privilege, network policy, pod security, secrets, audit logging. Awesome. Let's see the README, what it comes up with. Exam prep, install it. What's inside? There's 2 study modules, exam practice and lab challenges, and that's what we have right now. Awesome. Let's run it. Let's go to terminal and let's run it. Why not? There we go. Pip install rich, or pip and not working, not recognized. Why don't I have pip? I probably never installed it. Okay, we have that. Yeah, we have Python. Okay, quit. Come on, there we go. Py ensure pip dash upgrade. Let's get pip installed. Looking in the list, pip is installed. Pip. It's probably not in the path. That's what it is. It's probably just not in the path. All right. We're kind of running out of time here. That's going to be our next. I'm gonna see what I can do with the Kubestronaut exam prep capability here. Thank you for joining me today. It's been fun. I hope you've learned something. I hope I was able to share some insight. This is going to be running every Thursday. I'm looking for at least 5 repetitions. Take a look at the links I'm going to provide you with some links later on. And then, of course, I'm going to give you some homework. Install Minikube. Get yourself a virtual machine, set up a Minikube so that we can practice. We can run some of these exam prep things next week. All right. Good luck, everybody. And yeah, it was really, really awesome. Really, really awesome. KCNA. Let's take this one question. What is the difference between KCNA and CKA? So KCNA is really a basic exam. It's really more about the knowledge of all things Kubernetes rather than actually being able to run a lot of things in Kubernetes. Think of the associate exam as somebody who's just started with Kubernetes and wants to prove that they understand Kubernetes. They might not be an admin, they might not be a developer yet, they might not be a security engineer for Kubernetes. They will be at some point. And KCNA just gives you that first stepping stone, the first level of certification. CKA, the administrator, is proving that you know how to run Kubernetes, proving that you're going to be able to operate a Kubernetes cluster without majorly breaking things. You're still going to break some things, but you're not going to take a production application down because you don't know which command to run or what commands mean. All right, I hope that gave you a little bit of an insight. So think of your first step are KCNA, KCSA. Yeah, the recording will be on YouTube on the same link and on LinkedIn on the same link that you're watching from. So basically, just save this link in your save this link on your device itself. All right, so recording will be available right here, and it will also be available right here. So as you go to these links later on, as the show ends, you'll be able to see the recording itself. And this is coming from MD. And I've put the links into the chat. And I will put all the links to all of the components that I was using into the description of the videos. Cool. We are 2 minutes to time, so I got to get off the air as soon as I can. Thank you so much for watching. Thank you so much for being my live audience. Awesome to see that there was a turnout. There was a significantly larger turnout than I expected. Thank you very much, and I will see you next week, Thursday, 11 Eastern, same place, different links. Check my LinkedIn and the Dev Central LinkedIn and YouTube for the announcement for next week. All right, everybody. See ya.